my peeps? This Algebra Nation podcast brought to you by the University of Florida. Go LSU! Algebra Nation workbook, page 6. Here we go.
So what if you have like a big number and then like a little number put like in the corner? That's the question. You got a big number and then like a little number, and that of course we call what's known as an exponent. So when you read it, for instance, this is 2 to the exponent of 3. You might also hear 2 to the third power, or 2 cubed. This would just mean 2 times 2 times 2. So exponents are basically going to multiply out how many times that occurs. That's one way to think about it. 2 cubed, 2 to the third power, 2 to the exponent of 3 is 2 times 2 times 2, which you eventually get equal to 8, because 2 times 2 is 4, and then 4 times 2 is 8. So that's what I want you to do with these first few examples. Simplify. 3 raised to the second power would equal 3 times 3, which equals 9. Negative 3, all in parentheses to the second power, would be negative 3 times negative 3, which would also give you, well, negative times a negative is positive, and 3 times 3 is 9. But do be very careful. What is the difference between this expression and this expression? The one on the left, the negative is in parentheses. The negative is getting squared. The one on the right, the negative is not. Only the 3 is being squared. 3 squared, 3 to the second power, 3 times 3 is 9, and the negative you leave. So you do have to be very careful when you have parentheses or not. So if it's in parentheses, you would apply that exponent. If it's not, then you would not. That's my one little for you. So let's do it again. 2 to the third power would be 2 times 2 times 2, which we already saw is equal to 8. Is the negative being raised to the third power? Yes. This is negative 2 times negative 2 times negative 2. A negative times a negative is positive, times another negative will give you a negative, and then 2 times 2 times 2 is negative 8. In this case, is the negative being raised to the third power? No, because it's not in parentheses. You leave the negative alone, and then 2 times 2 times 2 would give you 8. So make sure you know the difference here. And again, be very careful, because even though you had parentheses, we still had a negative when it was cubed, but it was positive when it was squared. That's a good discussion to have overall. Why in some cases is it negative, and why in some cases is it positive? What are the differences? The big one is, when it's in parentheses, you apply the power to the negative. Not in parentheses, you do not. Next up, when multiplying exponential expressions with the same base. So they have to have the same base, like 2 and 2, or x and x, or b and b. What do you do with the powers? You add the powers. Because g squared means g times g, and g cubed is g times g times g. So how many of those do I have total? That would be g to the 5th power, meaning that when you multiply, you keep the base, but you're going to add the exponents. That's what happens when you're multiplying two terms that have the same base. So 2 to the second power times 2 to the 4th power would be 2 to the 2 plus 4, 6th power. Same idea with variables. X squared times x to the 4th. X to the second power times x to the 4th power would be x to the 2 plus 4 would give you 6. B to the third power times b to the... When they don't give you a power, what does that mean? Be a first power, right? Because any number by itself or any variable by itself is already raised to the power of 1. There's one of them. This would be b to the 3 plus 1 will give you b to the 4. So I want you to try these. Pause the video, give these 3 a try, and see if you can go ahead and combine these exponential expressions. You ready? Pause now. A to the 5th times a to the 7th, 5 plus 7 will give you a to the 12th power. Z to the 1st first times z cubed will give you z to the fourth, and that is the answer. Ooh, y to the negative 3 times y to the fifth would be y to the negative 3 plus 5. Negative 3 plus 5 will give you 2. You might add and subtract positive and negative numbers. Be very careful here. So that's when you're multiplying. When you multiply, you add. So when you
I think it's time for a brain break. Don't let this happen to you on the EOC. Back to work.
divide, what do you think you do? When you divide, you keep the base and subtract the powers. Subtract. That's subtract, that's subtract. Let's remember, I am math, so my English, there we go, subtract. Yes, I can spell. G to the 6 divided by G squared. G to the 6 means G times G times G times G times G times G. And G to the second power would be G times G on the denominator. So remember with fractions, what do? You simplify. G divided by G would simplify, and another G divided by G would simplify, and how many do I have left? 1, 2, 3, 4, and they're on the numerator, giving you G to the fourth power. But again, when you divide, you just combine by subtracting. 6 minus 2 will give you 4. W to the 6 divided by W to the third, 6 minus 3 will give you W to the 3. X to the 7th divided by X to the 4th. 7 minus 4 will give you X to the third, or X to the power of 3. Y to the 5th divided by Y to the first. 5 minus 1 will give you Y to the 4th. You good? Ready to try it yourself? Once again, pause the video, give these 3 a try. Pause now. Z to the third divided by Z to the fifth. 3 minus 5 would give you Z to the negative 2. X to the 10th divided by X to the fourth. 10 minus 4 will give you X to the 6th. Y to the first divided by Y to the fifth would give you 1 minus 5, or Y to the negative 4. Now you might be looking at these and going, wait, negative powers? And we're going to discuss what happens with these negative powers in just a little bit, so stay tuned. When you multiply, you combine by adding. When you divide, you combine by subtracting. What if you have an exponent raised to another exponent? Again, what if you have a power to a power? When you have an exponent raised to another exponent, you keep the base and x squared cubed would be x squared times x squared times x squared. X squared would be x times x, another x times x, and another x times x. How many is that total? That would be x to the 6th power. Which means what am I doing? I'm going to multiply the powers. I would multiply the powers when I have an exponent raised to another exponent. Y to the 4th squared would be y to the 4 times 2 gives you 8. Oof, 2x cubed to the 5th. Well, remember, 2 is raised to the 1st power. So 5 times 1 will give you 2 to the 5th. 5 times 3 will give you x to the 15th. So again, we're just multiplying the powers right now. Want to give it a try? One more time. Go ahead and pause now. Five times 4 will give you z to the 20th. Remember, 3 is raised to the 1st power. 2 times 1 will give you 3 to the 2nd power. 2 times 2 will give you a to the 4th. 2 times 3 would give you b to the 6th. And if you want to simplify any more here,
That's all, folks. Dun, 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 dun.